Repair a broken engine electrical system wire. Imagine you are performing a scheduled maintenance check on an aircraft that just came out of a dusty, high-humidity environment. As you inspect the accessories section, you spot a wire with frayed insulation and corrosion on a terminal lug. The engine runs fine for now, but under vibration and electrical load, that wire won't hold. In engine electrical systems, a damaged or compromised wire isn't a minor issue. It's a direct path to system failure. So how do you fix it, correctly and safely? Let's walk through the process of repairing damaged engine electrical wires, step by step, from inspection to final connection. Start by identifying the wire material. Is it copper or aluminum? That one detail determines everything about the repair. Aluminum wires can't be temporarily spliced. They must be handled using specific components and techniques. One mistake to avoid is assuming that copper and aluminum can share the same terminal hardware. They can't. If materials aren't isolated properly, it will lead to galvanic corrosion and connection failure over time. Once you've confirmed the wire type, preparation is critical. Thoroughly clean the wire and the surrounding repair area with an approved solvent. Remove any signs of oil, dirt, or corrosion. When you are trimming the damaged ends, insert wire into exact center of correct cutting slot for wire size to be stripped. Each slot is marked with wire size. Close handles together as far as they will go. Release handles, allowing wire holder to return to the open position. Remove stripped wire. Never reuse corroded terminals or connectors. Even a small amount of residue can cause interference with conductivity, which leads to heat buildup and electrical issues down the line. Now match the repair method to the wire type when replacing a terminal or lug. If you are working with aluminum wires, use aluminum lugs that come pre-filled with a petrolatum zinc dust compound. This compound chemically breaks down surface oxidation during crimping and seals the joint afterward. Don't wipe out the compound, and don't remove the internal plastic seal. These are critical to the joint's long-term stability. If you are working with copper wires and it's small enough that it doesn't fully fill the lug barrel, here's what to do. Fold the wire over once. This increases the contact area. Crimp it securely. Slide vinyl tubing over the joint to insulate it. Tie off the tubing to prevent movement. Make sure that the distance from the end of the insulation to the end of the conductor is 1/2 of the length of the insulation that is removed. For example, if the exposed wire is 1/2 inch, then when folded, the exposed wire should be 3 by 4 inches. Failing to properly size the wire to the terminal results in a loose, unreliable connection. But what if you don't have a terminal available? If the wire is copper, you can make a temporary emergency repair by stripping about 1/2 inches of insulation from each end, twisting the bare wires together, and soldering the joint using 60 by 40 tin lead resin core solder. After soldering, slide the correct size heat shrink tube over the repair. Apply heat on the shrink tube until the tube has covered the repair. Keep in mind, this is a temporary repair, and always refer to the specific aircraft manual for direction. Not all aircraft manufacturers will allow you this type of temporary repair. Finally, once the repair is complete, secure the repaired wire to the terminal block. If you're using an aluminum terminal, cadmium-plated steel or aluminum alloys washers on both sides. Torque the hardware according to specifications. Too much torque or too little can both lead to heat buildup and eventual failure. Before you close up the panel, go through a few final precautions. Always use plated brass washers between aluminum and copper lugs to prevent galvanic corrosion. Do not place lock washers directly against aluminum lugs. Always use a flat washer between lock washer and terminal. Incorrect sizing can lead to poor contact or mechanical interference. Always use a torque wrench to achieve the specified pressure. Repairing a broken electrical wire isn't just a task. Every repair matters. Always remember, every repair is not approved on every aircraft. It's what keeps the aircraft safe and the systems reliable. Follow the approved manual procedure, respect the materials, trust the process. Because in aviation maintenance, accuracy isn't a detail, it's a discipline.